Welcome to Sundar's lecture. This is lecture number 58, and in this lecture we are going to see reciprocity theorem. So before that, what are all the topics we have seen in the previous class? We have taken intelligence theorem in the previous class, and we have discussed what is intelligence theorem. Before that, we have discussed what is power delivered and power absorbed in an electric network, and then we have proved what is intelligence theorem with two different network but with same topologies, and we have concluded that what we have concluded, see, this is the final conclusion, that V1 I1 dash may be first network voltage and second network's current may be the same branch currents, and addition of all these kind of things should be is equal to 0. So what it actually meaning, this equation should be equal to this equation. See, V1 I1 dash means first network voltage, second network voltage plus first network voltage in the second branch and the second network current in the second branch, and then we have written like this, that should be is equal to, maybe these zeros can be cancelled out, right? So we can equate these two. So that is the whole idea. That is what intelligence theorem is actually means, right? So now what we will do, today we will take reciprocity theorem. We have to use intelligence theorem to prove the reciprocity theorem, or the content in the reciprocity theorem will follow the intelligence theorem. Anyhow, see, we have taken two networks. This is let me explain you certain things. Please be carefully listen these kind of things, because once you listen this one, you can write directly what will be the current in the other network by seeing the first network. That is what the whole idea about the reciprocity theorem, right? So now this is network 1. We have a network. See, this is the network actually. This network has been drawn like this. Anyway, see, this is the first network, and in this network there is a voltage source and there are resistance. Maybe it is connected like this, and voltage I am considering it to be V1, and I am current in this branch I am considering it to be I2. Okay, so this point is 1 and 1 dash. This point I am considering it to be 2 and 2 dash. So inside this 1 and 1 dash, 2 and 2 dash, there will be resistance, only resistance. There should not be any sources present. That is the idea. See, I have just drawn this diagram here. So current I have assumed in this direction. Try to understand. I have assumed current in this direction, right? So this is the network 1, and in network 2, see, this voltage source I have just taken here in this branch, and all other things will be same. Everything will be same. See, this resistance, this resistance, this resistance, all the values of the resistance will be same. That is the idea, right? This one, now in this branch I have assumed the current in the same direction. See, same direction, that is I1 dash. I am considering it to be I1 dash, and the voltage here I am just considering it to be V2 dash. So point 1 and 1 dash, 2 and 2 dash, inside this the resistance connected should be same value, and also it has to be the same topology. See, the same topology. I have not written any resistance values here, but to understand I have just written these kind of diagrams, right? So voltage source at this point, and I have short circuited this place. In the second network I have short circuited this place, and I have placed the voltage here. Maybe these voltage V1 and V2 may be same or not, may not be same. That depends on the circuit. It is not an issue. So we will see what is the reciprocity theorem, right? Proof for reciprocity theorem. So now here you apply intelligence theorem in the network, in two networks, right? So what is that? Tell me. V1 in this branch current, this branch voltage is V1, and what is the other branch current? The same network, right? Topologies are same. So maybe I am considering these two networks, right? This network and this network. So this is V1, and here what is the current? It is I1 dash, And what is the second one? Here I will go here, plus, see what is the voltage here? Voltage here, it will be 0, right? It will be 0. And so here it will be, voltage will be 0. And what is the current in the other network? See, oh, I have missed this. So this will be I2 dash, and here also it will be I2 dash, right? So now this will be into I2 dash, and plus, see whatever the resistance here, everything, I am just summing it into k number of, maybe this will be common for all the circuits, right? So I have done this. So here voltage, that means Vk into Ik dash. I've just written like this because this resistance, all the resistance are same, and I have written like this, right? And this should be is equal to, and I am going here now. So what is the voltage in this branch, second network? That is 0 into, what is the current in this branch? It is I1. It is I1 plus, what is the voltage here? It is V2. It is V2. What is the current here? That, sorry, this voltage is V2 dash. This current will be I2 plus, same thing, right? What is the voltage and current in every resistor? That will be same, right? That will be same. So summation k upon, it will be Vk dash into Ik, because the circuit voltage and the circuit current I am just taking, right? So these two should be equal. Maybe I will write it down. So V1 I1 dash plus, this is 0, right? I'm not going to write this one. So it will be summation k into, see what I can write this one, Rk into Ik into Ik dash. This I have just broke this Vk into Rk into Ik, right? So that should be is equal to this term V2 dash into I2 plus summation k. This also can be written as Rk into Ik dash into Ik. See, both resistance are same in this circuit, should have same value of resistance in this circuit. Now you see, if these two, now you compare these two, this has to be same. This has to be same, because that is what we have seen in the previous class too, right? These should be equal. These should be equal, right? Whatever it may be, that should be equal. So what I can do, this term, because if you bring this to other side, that becomes negative, right? So this term and this term should be equal to 0. Right? Then what we can write it down, see, this is the intelligence theorem actually. So V1 I1 dash should be is equal to V2 dash into I2. So this is actually intelligence theorem, and I can write it down, see V1 by I2, that should be is equal to V1 by I2, V2 dash by I2 dash. I can write like this, or if you want to just maybe there are so many ways to write this. Maybe V1 by V2 dash should be is equal to I1 dash by I2, and so many things, right? So this is the intelligence theorem. What it actually telling is, if you know this circuit and what is the voltage, and if you find what is the current here, then if you have a circuit like this, and if you know what is the voltage V2 dash, then you can easily find what should be the current here. Without solving this circuit, you can easily get this one by using this relationship. That is the idea. Okay, fine. Now let us take a numerical example so that you can easily understand. Right. So we have taken an example, numerical example. let us try to find what is the current in this branch. I have not told you anything else. Let me find what is the current in this branch, which means this one. Maybe I will call it as I1, and this one I am just calling it as V1, right? Maybe I2. I'm just calling it as I2, right? So let me find this one now. So how will you find? See, this is the circuit. If I want to find what is this current, maybe this is I1. I'm just taking it as I1 just to understand. Maybe how will you find this current and this current? It is very simple, right? So these two resistors are connected in parallel. If you want to find what is the current I1, maybe if you simplify whole network, that then there will be some only one resistance, an equivalent resistance will come across this voltage source, and I can do like this, right? So I1 can be written as, that should be is equal to, these two are connected in parallel and this is connected in series with this parallel combination. So it will be V1 divided by, maybe V1 divided by this resistance is 0.6 plus this is connected in series, right? So sorry, parallel, right? So it will be 4 plus 6 into 4 into 6. So what is V1? V1, which is equal to, it is 30. So if you simplify this, then you will obviously get what is the current flowing here. So if you simplify, you will get I1, that should be is equal to 10 amperes. You just simplify by yourself, obviously you will get the values. So this is the whole idea. So if you maybe this will be 10, right? It will be 24. So 24 by 10, you will get 2.4, 2.4 plus 0.6, it will be 3, 30 by 3, it will be 10 amperes. Okay, maybe we will do by ourselves. Anyway, so this current is 10 amperes now. Now you know this is 10 amperes, and if this 10 amperes is coming here, then apply current division rule to get what is this current and this current. That is also very simple, right? Because if you apply maybe this point, I'm just considering it to be A. So I'm just applying current division rule. Any of these kind of things you would have already known, current division rule at A, point A. Then what you will get, if you want to find what is the current in this branch, which means I through 4 ohms, that should be is equal to, what is the total current? That is 10 amperes. 10 amperes into what is the opposite resistor? It is 6 ohms divided by what is this total resistor? Then it will be 10. Then what happens? This 10 will be cancelled out, and this will be, I through 4 ohms will be what? I through 4 ohms will be 6 amperes. And if this is 6 amperes, if this is 6 amperes, then what happens to this one? So 10 amperes is coming in, 6 amperes is going away, then this should be 4 amperes. So I through 6 ohms should be is equal to, sorry, I through 6 ohms should be is equal to 4 ohms. And we know that this current is now 4 amperes. So we will write it down. What is the value of current? So I1 is equal to 10 amperes and I2 is equal to, what is the I2? 4 amperes, right? So this is what we have found with this circuit. Now what I will do, I am just going to redraw this circuit by placing this voltage source here. See, we will do that. See, I have drawn this diagram now. So just replace this voltage to this side. That is what I have done. Now what I have taken, I have just taken, this is now I2 dash and this is now I1 dash, right? This is what I have done now. So now what you do, you just try to apply intelligence theorem here. Since what is the current, what should be this current, and you can apply, because you see all the networks are same, right? Both topologies are same and these resistance are same, and you know what is the voltage here, current here. And if you want to know what is the voltage, what is the current here, then you can apply intelligence theorem. What is intelligence theorem? So you see, what is this value? V1 I1 dash should be is equal to V2 dash into I2. That is the idea. So it will be maybe V1 I1 dash, V1 I1 dash should be is equal to V2 dash into I2, V2 dash into I2. This is the Intelligence theorem, right? So what is you want to know what is I1 dash? So what is I1 dash? Then that should be is equal to V2 dash into I2 divided by I1 dash. So what is this value? What is V2 dash? You know that this is 30 volt. This is 30. And what is I2? What is this branch current? That is 4. This is 4 divided by what is I1 dash? What is I1? Okay, this is not I1 dash, right? This is actually maybe I made a mistake. This one, if you bring this one to here, this is V1, right? So what is V1? V1 is 30. And if you cancel these two, what you will get? What you will get? I1 dash should be is equal to 4 amperes. I1 dash should be is equal to 4 amperes. Then what should be this value now? This value should be is equal to 4 amperes. So this is now 4 amperes, means this is, if you simplify this, then you will obviously you will get these kind of things. So this is the final expression that this is the 4 amperes. Now this will be 10 amperes. Maybe you can get this one. This is 10 amperes and this will be 6 amperes. You simplify this. See, I have not simplified this network, but with the knowledge of what is that reciprocity theorem, what I have just got directly what should be this current. See, in this network, both voltages are same. This voltage and this voltage are same. So what you can do further, you can simplify this this expression. What is this expression actually? See, I will write it down here. V1 I1 dash, that should be is equal to V2 dash into I2, right? These two voltages are same, right? V1 and V2 dash, because V1 is 30, V2 dash is also 30. So these two will be directly cancelled out. So what is the final expression? I1 dash should be is equal to I2. Should be is equal to I2. That is what we have got. See, I1 dash is equal to I2. That is what we have got. Anyhow, this is the intelligence theorem. This you just try to understand yourself. So if you know what is this current, and if you replace this branch, short circuited branch with this voltage, and then this branch current should be equal to this branch current. That is what we have got here. That is what we have got here. Try to understand. And you take many more examples. Maybe you take a different voltage. Maybe you see, I will draw this network with a different voltage source. See, I have taken this circuit now with a different voltage source. Right? So what should be this current? Straight away I can write down by using reciprocity theorem. V1 I1 dash should be is equal to V2 dash into I2, and I should know what is I1 dash, so it will be V2 dash divided by I2 divided by V1, right? So then what is this value? What is V2 dash? It is 10 volt into what is I2 we have got. I2 is 4 amperes. That should be divided by what is V1 now? V1 is 30 volt, right? V1 is 30. So what you will get, this 0 and this 0 will become 4 by 3, right? So what is the final answer of I1 dash for this circuit? It will be 4 by 3 amperes. It will be 4 by 3 amperes. You can directly write. This value should be 4 by 3 amperes with a different voltage source, but same topology. This network has been connected like this. Then if you know what is this current, then obviously you can find what is this current. This is the reciprocity theorem. Maybe you can take same voltage, then it will be I1 dash is equal to I2. If you are taking a different voltage source, no problem. You just write down the reciprocity theorem's equation, then you simplify this, you will get what is this current in a single stroke. It is not necessary to simplify the circuit again to get what is this current. That is the idea. This is the reciprocity theorem. Sorry, this is the this is the reciprocity theorem. Thank you. You go through this. In the next class, we will take a new topic.